Alright, question number 3 just wants to determine if the following equation has x-axis, y-axis, origin, or none of these. So I did forget to mention, so let me go back to problem number 1 whenever I was giving you guys the definition. So you compare the original to negative f of x, or f of negative x. You compare the original to negative f of x, and then you compare f of negative x to negative f of x. The first one is even, which is y-axis symmetry. This one in the middle is x-axis symmetry. It does not have a special name. And then this third one is odd. It is also origin. Okay, so when they're asking for origin, they're just asking for this third case. So these are the 3 types of symmetry, and it is possible to have more than one. You can have any combination of any 2, or you can have all 3 of them, or you may not have any. Okay, so this question wants to know, does this function have x-axis, y-axis, origin, or none? Okay, so here's what we want to do. A couple things. You can solve for y, which I mean, we don't necessarily have to, but let me just give you the basics. 2x plus y squared equals negative 2. Okay. This is my original function. The first thing I'm going to do is make x negative and then simplify. So this is the same thing as f of negative x. I'm going to say 2 times negative x plus y squared equals negative 2. Okay? Simplifying, we will have negative 2x plus y squared equals negative 2. Okay, so this is my new function. This is the same thing as f of negative x. That's making the x negative. Okay, this is my original. Okay. Then we will do negative f of x. Okay, so this is making the y negative. Okay, so in this time we will do 2x from our original equation plus, this time it'll be y, negative y squared equals negative 2. So this time we make the y negative. This is what negative f of y means. Okay, when we simplify, we would end up with 2x plus negative y times negative y, or negative y squared, becomes positive y squared, and then still equals negative 2. Okay, so here is that one. And then the third one, origin. When we have a function, you make both x and y negative. Okay, so this time we're going to do 2 times negative x plus negative y squared equals negative 2. Simplifying, we end up with negative 2x plus y squared equals negative 2. So this is x, alright. This is what we get for the third one. Okay, so normally I just compare this to this, this to this, and compare these two. It will be the same result, making both negative. But I'm just showing you all 3. So we're just going to compare each of these to the original. So is this the same? It is not. So that means it does not. It's not even. Okay, not symmetric about the y-axis. Now, are these two the same? Okay, they are. If you compare every step. So that means when you change y negative, it's the same. So this means x-axis. Okay. And then if you look at the third one, you compare those. It is not the same, so it does not have origin symmetry. So this one in the middle, when we change y negative, starting here and simplifying, it had x-axis symmetry because that's the same.